Good morning students, my name is Ashwant. Today we are going to discuss one of the important chapter in your chemistry, that is coordination compounds. Without any further delay, I am getting into this chapter. But before that, I just want you to tell you what are the things that we are going to discuss in this chapter. First one, we'll talk about the nomenclature. The nomenclature of coordination compounds. Second, we will discuss the isomerism. Third, we will discuss the valence bond theory or VBT, valence bond theory. And the finally last, we will discuss the crystal field theory or CFT theory. Okay, you might have noticed that I have missed Werner's theory. Werner's theory. But Werner's theory is a very basic theory, very simple theory. By taking one coordination compound example, we can understand all points involved in the Werner's theory. So our main focus for this session will be nomenclature, isomerism, valence bond theory, and then the crystal field theory. Once you have covered all these points, these 4 points, you can probably crack all the questions that comes from the coordination compounds. It is a very simple chapter and easy to score. So, we are going into the nomenclature first. We are going into the nomenclature. Okay, let's look into by writing a compound. Let's say this is a coordination complex. Okay. Before that nomenclature, let's talk about what are the basic terms. I think you all know these things. This is the coordination sphere, which is I represented it in a square bracket. This is a coordination sphere, right? The cobalt is called the central metal atom or ion. Central metal atom or ion. And you could see ammonia and chlorine, right? These are what? Ligands. And one species outside the coordination sphere, that is called counter ions, right? So you could see something is inside the coordination sphere and something is outside the coordination sphere. Werner, that we call Werner's theory. Werner called this as primary valency, and the species inside this coordination sphere, apart from the central metal atom, that is called secondary valency. Okay, so in coordination complexes, there are 2 types of valencies are present according to Werner: primary valency and secondary valency. Secondary valency is nothing but the ligands, and primary valency is counter ions. Okay, now what type of bond is present in between these counter ions and ligands that we have to discuss. Let's say if you take HCl, what type of bond is present in HCl? This is sharing of electrons, right? 1 electron from hydrogen and 1 electron from chlorine to form a covalent bond, right? It is a sharing of electron between hydrogen and chlorine. But is there any sharing taking place in this one? No. Both electrons are shared by ligands. In this case, nitrogen is donating both the electrons to the central metal atom, that is cobalt. You can represent it as something like this is cobalt. See, NH3. Both electrons are donated by ligand, that is ammonia and then chlorine. Okay. So what type of bond is that? That is your coordinate bond. Coordinate covalent bond, or simply you can say that is coordinate bond. Okay. Ligand forms coordinate bond with the central metal atom. And what about your counter ions? Does counter ion also form coordinate bond? No. Counter ion forms ionic bond. Counter ion forms what? Ionic bond. So again, central metal atom or ion, then ligands, and then the counter ions. So we talked about secondary valency and primary valency also. What is the secondary valency of this compound? Which is equal to the ligands, number of ligands is equal to 4 plus 2, 6. And